Hello, in this video we will find the exact value of each of the remaining trigonometric functions of theta. We are given that secant of theta is -3 and tangent of theta is greater than 0. We can use a reference triangle to solve this problem, or we can use definitions of trigonometric functions of any angle, which are a little bit faster to do. So I'm going to use sine of theta equals to y out of r, cosine of theta equals to x out of r, and tangent of theta equals to y out of x. So we are given that secant of theta is equal to -3. It's a reciprocal function of cosine. So cosine of theta will be equal to reciprocal of -3. -3 is a whole number, so it's out of 1. So reciprocal of -3 will be -1 out of 3. And this is our cosine theta. So right now we know that r is equal to 3 because r is always positive. This will make x equal to -1. And we just need to calculate y. But before we calculate what y is equal to, we need to know the sign of y. So I'm going to draw x and y axes and label the signs of trigonometric functions in each quadrant. All students take calculus. This stands for all, sine and its reciprocal, tangent and its reciprocal, cosine and its reciprocal. So we know that secant and cosine are negative, so the angle theta cannot be in the first quadrant because everything is positive there, and it cannot be in the fourth quadrant because cosine and its reciprocal are positive here. We also know that tangent of theta is greater than 0, so tangent is positive, which means it cannot be in the second quadrant because only sine and its reciprocal is positive there. And it cannot be in the fourth quadrant because only cosine is positive there, which means that our reference angle theta can only be in the third quadrant around here. In this quadrant, x is negative and so is y, which means the solution that we will have for y value has to be negative. Now we can calculate the value of y using r squared equals to x squared plus y squared. You can absolutely use Pythagorean theorem, but you need to draw a reference triangle to do so. So let's substitute and solve. We have r is 3, so 3 to the second equals to x is -1, so -1 to the second plus y squared, and we get 3 times 3 is 9 equals to -1 times -1 +1 plus y squared. To solve for y squared we need to -1, so let's -1 on both sides. 9 minus 1 is equal to 8. This equals to, this adds up to 0, so we have y to the second. We know that square and a square root will cancel, so I'm going to take square root of y. Whatever I do to one side, we need to do the same thing to the other side. And we get that square root and a square will cancel, so we have y equals to, let's simplify this radical. Square root of 8, we can break down 8 into 4, perfect square, times 2. So we get square root of 8 equals to radical 4 times radical 2. Square root of 4 is equal to 2, and radical 2 will stay the same, equals to y. So y would be equal to -2 radical 2. So sine of theta is equal to y divided by r. Y is equal to -2 radical 2, so -2 radical 2 out of r is equal to 3. So sine of theta is equal to -2 radical 2 out of 3. Once we have sine of theta, we can also find cosecant of theta, which is just a reciprocal of -2 radical 2 out of 3, which will be -3 out of 2 radical 2. We need to rationalize this radical 2 in denominator, so one more factor of radical 2 will give us a square. That is an inverse of a square root. Whatever we multiply denominator by, we need to multiply the same thing into the numerator. This will give us negative 3 radical 2 out of 2 times radical 2 to the second power. Square root and the second power will cancel, and we get negative 3 radical 2 out of 2 times 2. So cosecant of theta is equal to negative 3 radical 2 out of 4. Tangent of theta is equal to y divided by x. Y is negative 2 radical 2 out of x is negative 1. We can simplify this and get tangent of theta equals to negative 2 divided by negative 1 gives us positive 2 radical 2, and 2 radical 2 will be the solution for tangent of theta. Once you have a tangent of theta, you can find cotangent of theta, which is a reciprocal of tangent, and a reciprocal of 2 radical 2 out of 1 will be 1 out of 2 radical 2. I'm working with the positive version of 2 radical 2 out of 1 because negative divided by negative will turn into positive. So we just need to rationalize cotangent of theta, and we have a square root in denominator. If we multiply it by one more factor of radical 2, it will give us a square that is an inverse of a square root. Whatever we multiply denominator by, we have to multiply numerator by the same thing. This will give us 1 times radical 2 out of 2 times square root of 2 times square root of 2 gives us square root of 2 to the second power. Square root and the second power will cancel. This will result in radical 2 in numerator out of 2 times 2. And we get cotangent of theta is equal to radical 2 out of 4. And this is our solution for cotangent of theta. That's all.